Pierce. This is Dr. Jones checking in. This is ANP2 Lecture Test 3 Video 11. Video 11. I gotta write that down or I'll forget. Video 11. I don't have enough working memory to keep track of video numbers in my head while I'm lecturing. So I'll write them down. It's a thing about executive skills and executive functions. There are some people that can keep track of time, just inherently keep track of time. And they're always on time, and they always end on time, and everything's on time. And I'm always so impressed. I can't do that. And so I, during a regular school year, have about a half a cajillion, which is not a real number, of alarms on my phone. It's time to go eat lunch. It's time to wash your spoon. So you can go to class. And so those executive function things that my brain doesn't do, like keep track of time, I use technology to do it for me. So there are workarounds for all the executive function issues that we have. You just have to look for them and make a habit to use them. It's not easy, and this has taken me decades, but you can get there. So, starting the timer. The page I am looking at looks like this: atrial systole, while the ventricle is in diastole. And numbers 1 through 8 in the note set and in the book match numbers 1 through 8 on the picture, which match numbers 1 through 8 on the picture in the test. So this picture is the picture in the test, and this picture is also on the final. Dun, dun, dun. So atrial systole. So this is the beginning of the, okay, I'm going to move me down here so that I can say this. Okay, atrial systole, this is our line here, and this will be our counts every 100 milliseconds or so. So atrial systole starts while we're still in ventricular diastole, as we know, because this is the whole passive filling bit. All right, atrial systole marks the beginning of the cardiac cycle and lasts for a 1 count, roughly 100 milliseconds. Number 1, atrial contraction begins. That's here. The atria contract, the AV valves open, blood is flowing into, the AV valves are open, not that they open here, but that they are open. And blood is flowing into the ventricles at the beginning of atrial systole. The ventricles are already roughly 70% full. Okay, we're going to move me off, and I'm half on the screen here. Hi guys. Okay, I'm here. Squished in the corner, but I'm here. Okay, so now let's talk about these lines. This blue line is the pressure in the left atrium, and this red line is the pressure in the left ventricle. Now these pressures will be the same on the right side, right atrium and the right ventricle, but we're following the left because that's what's on this chart. Okay. So at atrial systole, the beginning of the cardiac cycle, okay, there we go. The atria contract, which increases the left atrial pressure and also squeezes blood into the ventricles, so it increases left ventricular pressure. Okay. And then number 2, the atria eject blood into the ventricles, so that's here. And the atria squeeze the last 30% into the ventricle, which the book refers to as topping off the ventricles. And the ventricles are now full. So down here is left ventricular volume in milliliters. This is in pressure, specifically millimeters mercury. So left ventricular volume at 1 is still kind of high, and then we fill all the way to the top, and this is the end of ventricular diastole. And so this is called end diastolic volume. It's abbreviated here it's over here, faster, EDV, end diastolic volume, and that's the volume in the left ventricle at the end of diastole, end diastolic volume. Diastole was don't squeeze, relaxation. Okay, so this is how full did the ventricles get. Explain passive blood flow into the heart during atrial and ventricular diastole. We kind of already did that. And where's the blood coming from? It's coming from the great veins. Next question, what in the heck are great veins? So the great veins are the superior vena cava, the inferior vena cava, and the superior and inferior left and right pulmonary veins. So the 6 veins, 6 major veins, the coronary sulcus, we'll get there. Another coronary, so the coronary sinus, that's what it is. Coronary sinus, and it goes into the right atrium as well as the superior and inferior vena cava. And the left atrium, it's the superior and inferior left and right pulmonary veins. Okay, so where's the blood coming from? The great veins, those 7 veins. End diastolic volume is how full the ventricles are before systole, and systole is squeeze. Number 3, ventricular systole. The atria are now in diastole, atrial diastole. Okay, and atrial systole ends, boom. Number 3, the AV valves close, lub, right there. The AV valves close because you see how the blue line was on top and now the red line is on top? So there was more pressure in the atrium, and now there is more pressure in the ventricles, and the pressure in the ventricles, because the cuffs were open, the pressure in the ventricles pushes them shut, snaps them shut. Okay, so the AV valves closed, that's lub, which is heart sound subscript 1, capital S subscript 1. And number 4, which is on the next slide. Okay, isovolumetric contraction. So from here to here, all the valves are closed. So you're squeezing, you're pressurizing the fluid. So can you compress a liquid? Well, you can put pressure on it. And that's what you do during isovolumetric ventricular contraction. Okay, what do those terms mean? Iso means same. Volume is the total amount. Ventricle contract happens. So isovolumetric ventricular contraction, all 4 valves are closed, but the ventricles are squeezing and putting that the blood in the ventricles under pressure. Number 5, ventricular ejection occurs. So this is when you squish the blood into the arteries. The ventricular ejection is the technical term for squishing the blood into the arteries. I mean, the whole point of the heart is to pump blood, right? There it is, ventricular ejection. So the semilunar valves open, and that's what that says, the semilunar valve opens. And the blood goes into the great arteries. So this black line here is the pressure in the aorta. Okay, so let's be very clear about something. This blue line is atrial pressure. And this black line I'm kind of running out of space. That almost worked. That almost worked. Okay, so this blue line down here is atrial pressure. It's the pressure in the atria, specifically the left atrium. And here this black line, see, black line, bump, dicrotic notch. This is the pressure in the aorta, which is one of the two great arteries. So this is arterial pressure, and this is atrial pressure. So they look alike, they sound alike, and if you're a whole word person, they're the same word. Okay, I was taught with whole, I'm off screen again. So for us whole word people, we have to be very careful when we see these words to stop and double check. Double check when you see one of these words. Atrial refers to an atrium, left or right. Arterial refers to the arteries. The two great arteries are the aorta and the pulmonary trunk. Okay, give that a second to sink in. All right, why was I talking about that? We talked about isovolumetric contraction, that all the valves are closed, no blood is moving, and you're increasing the pressure in the ventricles. Okay, and then number 5, ventricular ejection. You push the semilunar valves open, which clearly I've already said, and the blood gets squished into the great arteries, which we mentioned are the pulmonary trunk and the aorta. And so this black line is arterial pressure, and it increases as the blood pressure squishes it open. Remember, it has lots of elastic fibers. It squishes shut, which causes the dicrotic notch. And the stroke volume, which is down here, is the amount of blood that got squeezed out with that heartbeat. Am I off screen again? I have a very small window here. And so the 6 stroke volume is down here. Yeah, that's not lined up very well. Okay, so number 6, the semilunar valves close. That's the aortic is a semilunar valve. The aortic valve is a semilunar valve. So this is your dub. Dup, I know, I just hate it. Just, no. I know, but yes, but I can complain all day long. Won't change anything, but I still get to. Okay, and then when the ventricles are empty, it's the end systolic volume because it's the end ventricular systole. I think the next slide should be an overview. All right. I'm gonna move me back in the picture, but out of the way. My curtain's not big enough, so I have a second curtain that's a different color, so that's why I try to keep it off the side a little bit so that it's not distracting. Okay, so as atrial systole ends, ventricular systole begins. Is the beginning of the cardiac cycle. Oh, I can shift back. Okay. I need one of those fancy desk chairs with like wheels on it. That would be fun. Okay. Although I'd probably be like fidgeting and moving the whole time because As atrial systole ends, ventricular systole begins. And ventricular systole lasts roughly 1, 2, 3. Roughly a 3 count. It's more like 270, not actually 300, but close enough. What pushes the AV valves closed? When ventricular pressure becomes greater than atrial pressure. Atrial pressure. Isovolumetric contractions are when the ventricles contract with all 4 valves closed. So we are increasing pressure, but not changing volume. Hence the name isovolumetric. Iso means same, volume means volume. Is my hair on this stuff? Teaching is more fun when I can't see myself. And what pushes the semilunar valves open? The aortic valve and the pulmonary valve are the 2 semilunar valves. The AV valves are the bicuspid and tricuspid valve. So the aortic valve, semilunar valves open when ventricular pressure becomes greater than arterial pressure. And remember the difference, blue line atrial pressure, black line arterial pressure. Big difference. Artery. Atrium. Ventricular ejection is when the ventricles eject blood into the arteries. Stroke volume. I've got a picture of that on the next slide. Let's talk about the dicrotic notch. Right here. Dicrotic notch is the drop and rise in arterial pressure when the semilunar valves close. And again, DUP. Okay, and that's S2, and it's more or less near the end of beat 4-ish. Okay, next picture. Okay, so the ECG, the P atrial depolarization happens halfway at the beginning of the cardiac cycle. So the P is the end of one cardiac cycle and the beginning of the next cardiac cycle. QRS complex is the atrial depolarization and the ventricle polarization. The atrial repolarization, the ventricular depolarization. And then here at the end of ventricular systole, ventricular repolarization. Is that right? It sounded right in my head. Double check that. Okay, so the end systolic volume. I don't know if the EKG, ECG is on the picture, is on the test, but these volume bits for sure are. So the end diastolic volume is how full is the ventricle before you squeeze the blood out. The end systolic volume is how empty is it. So for this, I like to think, because there's always volume left, there's always some blood left in the heart, I like to think of this as like the end of the tube of toothpaste. You will never, ever, ever get every drop of toothpaste out, just like you'll never squeeze out all the blood. You'll never exhale out all the air. Even with a collapsed lung, there's still a little bit of air in there. Okay, so the end systolic volume is how empty is your tube of toothpaste after you've tried to squeeze the last of it out. The end diastolic volume was how full was it when you started. The stroke volume is how much toothpaste did you squeeze out this time. Okay, so this is abbreviated stroke volume and diastolic volume and end systolic volume. Because this is the volume at the end of diastole, and this is the volume at the end of systole, and this is the volume for this stroke. Make sure I said everything on the note set. I've got end systolic volume, ESV, how empty the ventricle is at the end of systole. What pushes the semilunar valves closed, dub, that's the ventricular pressure, is less than arterial pressure. How are we on time? We have 1.5 minutes left, and we're going to finish this section. Okay, so 7, ventricular diastole. Top of page 20. Ventricular diastole continues through the last 4 counts of the cardiac cycle, plus 1 count at the beginning of the next cardiac cycle. The actual numbers there are about 430 milliseconds and then 100 milliseconds. I wonder if I can turn the timer off before it goes off, because now I'm bothered that the timer's about to go off. Pause. Okay, good. So number 7, isovolumetric relaxation. Again, all the valves are closed, but now we're relaxing. So no blood is moving in or out of the ventricle. It's always blood pouring into the atria. No valves, so always blood pouring into the atria. Number 8, the AV valve opens. Why? Because the pressure lines crossed. That's why valves open and close, because one chamber squeezes up more pressure than the other chamber, or it loses pressure, and that's what makes the valves close. The pressure lines cross. So AV valves open. Passive ventricular filling, the blood from the great veins fills the atria and the ventricles. Isovolumetric relaxation, again, ventricle relaxes with all the valves closed, no change in volume. And what pushes the AV valves open? Ventricular pressure goes less than atrial pressure. And heart failure is when you are unable to pump blood to the body tissues. And let's go ahead and finish this section 23. Here is the picture on your test. It won't have all the words, but the numbers are the same on the test. And the locations of the heart sounds. So you're between first rib, second rib, third rib, between the second and third ribs, on the left and right, and then here on the left, because a heart crosses the midline, but it's more to the left. So here between ribs 1, 2, 3, 4, 5, and 6, just off the side of the sternum, and then further out just at the level of the nipple, under the nipple between ribs 5 and 6. Now here's why you listen. Auscultate is the term for listen. In these different locations, here are the sounds heard, the valve location. These are where the valves are, the heart valves are. And so as you gotta try this, it's so cool. So get yourself a stethoscope and listen in these different areas, and you can hear different parts of the heartbeat emphasized. Lub-dub, lub-dub. It's crazy. And while you're at it, auscultate the lungs, because they're really cool, especially like down here in the ends, and see what you can hear. You know, but always, you can't do a normal breath when someone tells you to take a normal breath. So do all your normal breathing auscultation first, and then do the deep breaths, because once someone's told you to do a deep breath and they tell you to do a normal breath, it is not ever going to happen. Okay, all of that to say, definitions: stethoscope, that's what you put around your neck to make yourself look impressive. Auscultation is listening. Heart murmur is when the valves don't shut all the way, and it's literally the noise of the blood moving backwards, the wrong direction, and it makes a kind of a whooshy noise. And lub is heard at the end of count 1. I think I have a, there we go. Lub is heard at the end of count 1 when the AV valves close, and dub is heard at the end of count 4-ish when the semilunar valves close. The semilunar valves, the valves opening makes a tiny noise, which we normally don't hear and won't talk about. We usually talk about the lub and the dub, or dub now, which is the sound of the valves closing. So dubs are heard at the end of count 1, and dub is heard roughly near the end of count 4, and then we will start middle of page 20 next time. Okay, so we got through 20, so that was 19 and half of 20. All right, this has been ANP2 Lecture Test 3. Video, I just looked at it, 11. And it's pushing bedtime for me. So I'm going to call it quits for tonight and record more tomorrow. Thank you, as always, for tuning in. I appreciate that y'all are working so hard to learn this material. I know it's harder on your own when we're doing the online-only classes, but y'all are doing your best. I know it. If you're not, get your butt in gear. But I'm going to assume you're doing your best. If not, I expect to see your best as soon as possible. Now, okay, quick note. There's a book called The Four Agreements, and I've never actually read the book, but I like the fourth agreement best. And it's the one that speaks to me. It's like, every day, do your best. But furthermore, realize that every day your best is different. I mean, think about a day you've got a cold or the flu or your back is out. I mean, how much is your best on one of those days? It's a completely different story than when you're, happy and go lucky and it's sunny outside or foggy or whatever makes you happy. It's different every day. So as long as you are doing your best and learning at your capacity, then we are a-okay. Now, I like to pair that with Maya Angelou's when you know better, do better. So if you learn how you study and how to structure your time, maybe you need less structure, maybe you need more structure, maybe you're like me and you have to have a timer because you have no concept of time. Finding out what works best for you is one of my goals for you for this semester. Not only to learn this material, which of course I want you to learn, but also to learn how you learn, which will help you the whole rest of your college career. Remember 2 things. Hard work beats talent when talent doesn't work hard. And now I can't remember the other. What was the other one? Again, pushing bedtime for me. Do your best. Your best is different every day. When you know better, do better. Investing in your study skills will pay off for you. It's worth your time to invest in yourself. I mean, we're halfway through this class almost. When we take test 3 and lab 2, we'll be halfway through the material and probably halfway through the time because I usually schedule it at both halves right at the middle of the semester. So we're almost halfway and you've put this much time and energy and effort and determination into it. I say it's time to go all in. Thank you, as always, for tuning in. The education must go on. Dr. J out. As soon as I find the buttons. Command, Control, Escape. Thanks, guys.